Okay, hello everyone. So today we are going to continue with problem solving on phase change, but this time in calorimetry. Okay, wherein the phase change concepts will also be considered in calorimetry problems. Okay, so let's start. We have 4 example problems on this one, but make sure that you have understood phase change calculation very well before you watch this video. Okay, so let's have example number 1. The specific heat of mercury is 0.033 kilocalorie per kilogram Celsius degree. When a 1.0 kilogram of solid mercury is at its melting point of negative 39 degrees Celsius, is placed in a 0.5 kilogram aluminum calorimeter filled with 1.2 kilograms of water at 20 degrees Celsius, the final temperature of the mixture is found to be 16.5 degrees Celsius. What is the heat of fusion of mercury in kilocalorie per kilogram? So take note that the solid mercury is already at its melting point. Which of these systems will release heat? So you can see here that the solid mercury is at negative 39 degrees Celsius, so it's colder, so this one will absorb heat. The one which will release heat would be water and aluminum calorimeter. So let's solve. Okay, so you have here Q absorb is equal to the Q released. So this one is negative. So again, as I have mentioned, Q will be absorbed by the mercury, and then it will release by the water, plus it will release by the aluminum. Okay, so you can see there, negative Q water plus negative Q of aluminum also. And take note also that it's already at its melting point. So we have here MLF for mercury plus mass of the mercury, C of the mercury, delta T of the mercury is equal to negative mass of the water, C of the water, and then delta T for the water, that's negative Q for aluminum, which we have mass of the aluminum, C of the aluminum, and then delta T for the aluminum. So here we are looking for LF, or the latent heat of fusion for mercury. We are looking for this one. So we can derive first, or you can substitute and then get LF. But for this case, I will show you the derivation first. So we'll have negative on this side, mass of the water, C of the water, delta T of the water, minus mass of the aluminum, C of the aluminum, and then delta T for the aluminum. Then I'll transfer this on the other side, so that will be negative or minus mass of the mercury, C of the mercury, and then delta T for the mercury, all over mass of the mercury. So this one is our equation for the latent heat of fusion for mercury. Okay. So take note that for the temperature for water, the initial is 20, the final is 16.5. So this one, aluminum, the same. The initial is 20, then the final is 16.5. For mercury, the initial is negative 39, but the final would be 16.5. Okay, so let's now try to substitute the given here. Okay, so now let's substitute the given. You have the mass of the water there is 0. The mass of the water here is 1.2, so that's negative 1.2. Sorry. Okay, let's substitute the given. We have here the latent heat of fusion equals the negative mass of the water is 1.2 kilogram. C of the water is 1 kilocalorie per kilogram Celsius degree. So again, be consistent with the units. Since we have here specific heat capacity for mercury is in kilocalorie per kilogram, so we will use also a unit of kilocalorie per kilogram for the water. So that is 1. Ang delta T natin, the water is initially at 20, so ang final natin ay 16.5. Minus the initial is 20. So you can see here that this will turn out positive. Then you have minus, mass of the aluminum is 0.5. The C for the aluminum is 0.22 kilocalorie. That's 0.22 kilocalorie per kilogram Celsius degree. And then for the delta T of the aluminum, ang final temperature niya is also 16.5. Minus the initial is 20. Then we have transferred this one to the other side, so that will be negative also. The mass of the mercury given here, it's 1 kilogram. The specific heat capacity of mercury is 0.033. Okay, I'll just write delta T here. For the delta T, we have final temperature is 16.5 minus the initial is negative. Take note of that, negative 39. So do not forget that, negative 39. So we have here all over mass of the mercury, which is the mass given here is 1 kilogram. Yan. Our answer is equal to 2.8 kilocalorie per kilogram. So if we are going to analyze the cancellation of units, we'll have it on the next slide, just to show the cancellation of units. Okay, let's now just check the unit cancellation. So you have mass will be kilogram, and then C is kilocalorie per kilogram Celsius degree, and then delta T would be Celsius degree. So same for the other factors like this one. So yan din ay kilogram, kilocalorie per kilogram Celsius degree, and Celsius degree. Same with this one, kilogram, kilocalorie per kilogram Celsius degree, and then Celsius degree. So right now, you can cancel out. So you can now see that we can cancel kilogram here, and then Celsius degree. However, in our equation, you have to divide this one by kilogram. Okay, that's why our final unit is, so you can see here that will be kilocalorie per, that would now be kilocalorie per kilogram. So that's our final unit, kilocalorie per kilogram for the latent heat of fusion of mercury. Okay. So next. Okay, let's have the next item. For the next item, it's stated as this one. A cube of ice is taken from the freezer at negative 8.5 degrees Celsius. So this time, it's not yet at its melting point. Then, and placed in a 100-gram aluminum calorimeter filled with 300 grams of water. So look at the units, it's now in gram. At a temperature of 20 degrees Celsius. The final situation is observed to be all water at 17 degrees Celsius. So all ice has melted. What was the mass of the ice cube? So again, let's start with the equation. So you have Q absorbed is of course equal to and negative of Q released. So ang Q absorbed natin for this one, the heat will be absorbed by the ice. So that's Q for the ice is equal to the one which will release heat would be the aluminum and also water. But this time, the ice is not yet at its melting point. So from the initial is negative 8.5, aakit pa siya to 0, and then from 0 up, it will melt, and then from 0 to 17 degrees Celsius. So you can see that for the ice, it should be mass of the ice, C of the ice, because it's not yet melted, and then delta T for the ice to its melting point. So, ang delta T na to ay from negative 8.5 to 0. Take note of that. Plus mass of the ice, then latent heat of fusion of ice, kasi it will melt at 0 degrees Celsius, plus mass of the ice, pero this time it's already melted, C of the water, and then delta T. Okay? So there then equals, and we have negative mass of the aluminum, C of the aluminum, delta T. So it will not melt, so it's just this equation. Then for the water is also mass of the water, C of the water, and then delta T for the water. No phase change for the water here, and for the aluminum calorimeter. So we are looking for Mi. So right now, we can factor out mass of the ice and derive an equation for the mass of the ice. So, i-factor out lang natin yung mass ng ice. Yan, lalabas lang natin. So, tatanggalin na natin siya dito. Okay? So, there. After factoring out mass of the ice, we can now have the equation. Mass of the ice is equivalent to negative mass of the aluminum, C of the aluminum, delta T for the aluminum, minus mass of the water, C of the water, and then delta T for the water. Then divided by Ci delta T. So you can see here, the delta T again is from negative 85 to 0, plus LF plus CW delta T. Okay, again, take note here, LF here is positive because it will absorb heat. Because if it's melting, LF will be positive. Kapag freezing, LF will be negative. So, do not forget that. This is our equation, so we can now substitute. In the next slide, let's substitute. Okay, so let's now substitute. We have ang mass ng aluminum natin. For the mass of the aluminum, we have negative. Aluminum is 100. So, 100. C of the aluminum, it's 0.217. Or kanina we have used, I think, 0.22. So, it's okay. Let's use now, since it's the given here, 0.217. And then delta T for the aluminum, ang initial is 20, final is 17. So, that's 17 minus 20. Then next is mass of the water. The given here, the water is 300 grams. C of the water in calorie per gram, Celsius degree is 1. And then delta T, ang initial is 17, final is, initial is 20, final is 17. So that's 17 minus 20. Okay? Divided by, we have Ci, C of ice is 0.5. Ang delta T for this one ay final is 0 minus negative 8.5. Okay? So it's not that the final would be 17 agad. So that should be 0 minus negative 8.5 because it will melt at that point. Plus LF is 80. There. And then you have the last one plus C of the water is 1. And then delta T for the melted ice would be the final temperature is 17. Minus, of course, 0. Okay? Because it has melted at 0. Okay? So, calculating this one, you will have, okay, this one will be equal to, that's 965 0.1 calories divided by 101.25 calorie per gram. So you can now see we can cancel calories so that the final unit for the mass of the ice is in grams. The answer here is 9.53 grams. So the ice which has melted is equivalent to 9.53 grams. Okay. So that's for this problem. If you have any questions, lagay nyo lang sa comment in our Facebook group or also in the YouTube channel. Okay, next. Okay, this one will be different from the other examples. Yes, you can see here at a party a 0.5 kilogram chunk of ice, which is at negative 10 degrees Celsius, is placed in 3.0 kilogram of iced tea. Okay, let's assume it's just water at 20 degrees Celsius. So we will be using sea of water. At what temperature and in what phase will the final mixture be? The tea can be considered as water. So how can we solve this one? This time, we cannot say or we cannot tell that all ice has melted, unlike in the last situation. So how do we solve this one? If you're going to encounter this problem wherein there are situations that not all ice will melt, so what you're going to do is to compare Q absorb and Q release. So let's try this. The one which will absorb heat will be ice. And then the one which will release heat, of course, will be the water. Oops, it's not copper here. So when we are dealing with in this type of when we are dealing with this type of question, so let's assume first that all ice has melted. So assuming okay, mahirap mag-assume pero in physics kailangan natin mag-assume, diba? So let's assume that the temperature, let's say the temperature it's 0 degrees Celsius. Assuming that the temperature is 0 degrees Celsius. So let's also assume that the ice has melted. So let's check kung ano yung Q absorb of the ice. Okay, so let's continue with this item. Now, Q absorb, let's check what will be the amount of heat absorbed by the ice if lahat ng ice nagmelt. Okay, let's assume na lahat nagmelt. And let's assume that the final temperature is just 0 degrees Celsius, so it will not increase. So here, the mass of the ice, and then C of the ice, then delta T, kasi it from negative 10 to 0. Then plus, or it will melt, so it will absorb heat plus MLF. So let's check that value. We have the mass of the ice is 0.5 kilogram. C of the ice is, let's just check the table, is 2,100 joule per kilogram Celsius degree. Delta T for the ice is 0. Again, it's important to identify which is final and which is initial. So that's 0 minus negative 10. That will become positive. Then plus, mass of the ice is 0.5. Then LF of the ice, I'll just place it here, is 334 times 10 to the third joule per kilogram. Okay? So, solving that, the value will become 177. That's 177,500. Okay, what's the units? Or what's the units? Since the units will be in joule per kilogram Celsius degree, the heat will be in joules. Then, we are going to compare it with the Q released by the water. So, let's solve for the Q released. Q released by the water. So it's only water. We have mass of the water, C of the water, and then delta T for the water. So that will become a mass of water. We have 3 kilograms. C of the water is 4,186. Then delta T for the water, final is 0. Let's assume nga that the final temperature is 0. So 0 minus 20. Therefore, the heat released by the water is equivalent to 251,160 joules. And then, you analyze. This one is Q release, that's negative. The amount of heat release is 251,160 joules. Then the amount of heat absorbed is 177,500 joules. So you can see here that the Q released is still greater than the Q absorbed. So that means, this is, you have to have additional dito. May kailangan pa kayong ilagay dito so that they will be equal because thermal energy is conserved. Kung ano yung na-release, yun din dapat ang na-absorb. So something is missing here. Then we can say now that all ice has melted. However, the final temperature is not 0, but we can identify what is the final temperature by completing this equation. Okay? So let's continue. Okay, so let's continue. Now, we have mentioned that the final temperature is not 0, but it will increase. So, the final temperature will be in between 0 to 20. So, let's solve again. Q absorb is equal to Q release. So, there. Again, we have to add another term, this Q absorb that we were able to solve earlier. So, you have mass of the ice, C of the ice, delta T of the ice, plus mass of the ice, LF, plus, and that's the term that we have to add, mass of the melted ice, C, water na because it's already melted, and then delta T. But our delta T is from 0 to final TF, which is unknown. Then equals negative mass of the water, C of the water, and then delta T for the water. Wherein for the delta T, the initial is 20, the final is still unknown. So we can substitute now here. We have mass of ice is 0.5. C of ice is 2,100. T for the ice, final is 0 minus negative 10. 0 minus negative 10. Then plus mass of the ice, we have 0.5. LF of the ice is 334 times 10 to the third. Mass of the ice again, 0.5. C of the water, it's already, we are using joule per kilogram, Celsius degree. So C of the water is 4186 joules per kilogram Celsius degree. And then delta T is TF minus 0. Okay? So equals, we have mass of the water, negative, ang mass of water natin ay 3 kilograms. C of the water is 4186. Delta T of the water is final temperature, which is unknown, minus the initial is 20. Okay? So do not forget the negative here. So let's calculate. So you can see here, we were able to solve this one earlier, itong dalawang terms na to. So that is 177,500. Okay? Then we have the unknown. Okay, so let's continue. We have 177,500. And then this term 0.5 times 4186 times TF, that will be plus 2093 TF. Then equals this term, 3 times 4186 TF. So that is negative 12,558 TF plus 2,000 or 251,160. Okay? So combine all terms with TF. So here, we'll place it on the other side. And then this one, combine it there. So you will now have negative 73,660 equals negative 14,651 TF. Okay, so try to solve it also. And then for you to be able to get final temperature, of course, you have to divide negative 73,660 divided by negative 14,651. So that will give you final temperature. Our final temperature, so we'll solve that. Yeah, final temperature is equivalent to 5.03 degrees Celsius. Okay. So again, all water or all ice has melted. And then the final temperature is not just 0 degrees Celsius, but it has increased further to 5.0 degrees Celsius. That's why we have added this term, okay, this one. So that you will now have Q absorbed is equal to Q released. Okay, last one. So it's almost the same as the last item wherein it was not stated whether all water has changed into steam. Okay, so let's have the last one. A heavy copper pot of mass 2.0 kilogram is a temperature of 150 degrees Celsius. You pour 0.1 kilogram of water at 25 degrees Celsius into the pot. Then quickly close the lid of the pot so that no steam can escape. Find the final temperature of the pot and its contents. Determine the phase of water, whether it's all converted to steam or not. Assume no heat is lost to the surroundings. So let's assume again. Okay, let's assume that the final temperature, let's say it's 100. For the pot, it will decrease to 100, and then for the water, it will be 100, and then it will turn to steam. So Q absorb, the one which will absorb heat is the water. So we have mass of the water, C of the water, and then delta T for the water. Then, since we are assuming that it's 100 degrees Celsius and then it has changed into steam, so that will become positive mLV. Then let's check the value. We have the mass of the water, it's 0.1 kilogram. C of the water here, it's we are using joule. So C of the water is 4,186 joule per kilogram Celsius degree. Delta T, the initial temperature was 25, our final is 100, so 100 minus 25. Okay, that is for the first term. Then plus, mass is 1 kilogram, and then latent heat of vaporization is this one, 2.256 times 10 to the 6 joules per kilogram. So the heat absorbed, let's check what is the amount of heat absorbed. Okay, let's check for the heat absorbed by the water. So the heat absorbed by the water is 39,000. Okay, so this one is equivalent to 226,018.6. Okay, the unit is in joules. Since we have used the unit for C is joule per kilogram Celsius degree, and then the unit for latent heat of vaporization is joule per kilogram, so our heat here is equivalent to joules. So let's now check the Q released. The one which will release heat, of course, will be the copper. So we have mass of the copper, C of the copper, and then delta T of the copper. So you have here mass of copper is 2 kilograms. C of copper is 390 joule per kilogram Celsius degree. Again, we are assuming that the final temperature is 100. So 100 minus 150. The heat released by the copper is 39,000. Yeah, 39,000 joules. So that means you can see here that the Q released is actually greater than the Q absorbed. Therefore, we have to adjust sa Q absorbed. So that means the heat released by the pot or by the copper is not enough to turn all water into steam. So let's check this one first. Yeah. This value, 0.1 kilogram times 4186 times 75. So you can see here, if we are going to solve this one, try to solve it using your calculator. It will become, okay, this one, try to solve this term first. Yan, 0.1 times 4186 times 100 minus 25, that will give you 31,395. So I will just write it to the next slide. So that means, magiging less naman siya if we will only consider this part at tatanggalin natin to, that means kulang naman siya because it's only 31,395. So we have to have additional term. So we can now say that the water has actually reached 100, pero not all water has turned into steam. Okay, so let's solve. So let's now have our equation. Q absorbed is equal to negative Q released. So you have here mass of the water, C of the water, delta T of the water, plus not all water was turned or has turned into steam, so that will be X. So we can check this one. How much water has actually turned into steam? So X LV. So only a portion of the water was converted to steam. Equals mass of the pot or the copper, C of the copper, and then delta T for the copper. So take note that it's negative. So mass of the water, ang mass ng water natin ay 0.1. C of the water is 4186. Delta T for the water, the final temperature is still 100. Minus the initial is 25. Plus, we are looking for the amount of water which has turned to steam. Then LV is 2.256 times 10 to the 6th equals negative mass of the copper or copper pot, we have 2 kilograms. C of the copper is 390. For the delta T of the copper, final temperature is 100, so that's 150 ang initial. That's 100 minus 150. So that will be, we now have equals 39,000 minus 31,395. So this is 39,000 minus this. Then you have divided by 2.256 times 10 to the 6. So that will give us the mass of the water na nag-convert sa steam. So that is only 0.0033 kilograms only. Or it's actually equivalent to 3 grams na. So in this situation, not all the water place has undergone phase change, okay? So only a portion of it, which is 3 grams. So that's how you solve it. In these types of question, what you're going to do is to assume the temperature. Ang pag-assume natin ng temperature, it's either sa freezing point, 0 degrees Celsius, or boiling point, 100 degrees Celsius. Ganun lang. And then you check the amount of Q absorbed and then Q release, and then you will make a decision depending on which is higher, so that you can make adjustment on the other value. Halimbawa, Q absorb nyo ay higher kumpara dun sa Q release. So that means na sobrahan na kayo ng terms sa Q absorb. So you adjust the Q absorb, okay? So again, if you have questions, just send message or write in the comment below. Okay. Alright, so that's the end of phase change and calorimetry. In the next meeting, we'll have a new topic. Bye, everyone!